So the last part, I'm going to talk about some works that were done in the domain of tone and rhythm, which are basically prosodic features. What we have done in the area of tone and rhythm to basically see if there are dialectal differences between in the different languages we were looking into. So I don't probably have to explain to you tones are tone languages are languages where you the F0 difference. The most famous example is the Chinese example, where you have the one neutral tone in Chinese. So you have the ma, 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 which basically indicate four different meanings. Those of you who have read the Moira Yip's book on tone, then all of you would know that 67% of the world's languages are tonal. Unfortunately, it is not the case. 67% of the languages are basically smaller languages. And if you look into the Northeast India, then almost all Tibeto-Burman languages except all Tibeto-Burman languages are more or less tonal. So that makes the count in Northeast 300 tonal languages that are spoken. And imagine, like, how many tonal languages we have worked on, and we still get a little bit like insecure about our own works. But they are like, if you are not working on these 5 languages where tones are known, you have like 245 other languages where you can work on. So I strongly encourage you all to do that. But I am happy with my same old Mizo, which I have been working on since 2005 or sometime. So here, as an example of very complex tone system from Northeast India, I look into the Mizo system. Well, they are more complex because simple itself can be complex. Look at the Angami tone language, Angami tones. They have at least 4, as far as we are concerned, 4 level tone, ta, 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 ta. And that is the most complex system because there is no other variation, but they're all level, 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 level. And it is a huge task to actually phonologize 4 level tones. Mizo, in that sense, a little bit probably a little bit simpler. Nevertheless, this is these are 4 Mizo words with the same syllable but different tones.
Tongue, tongue, tongue.
Sorry.
Tongue, tongue, tongue.
So this is one inherent problem here, that the first one gets, I don't know how to do the, no.
Tongue, tongue, tongue.
So the first one is eaten up by the PPT, which is tongue. Then the next one is falling, low, and rising. I would have done these 4 tones. I did the Chinese, right? Because there is no Chinese speaker here. But there is at least one Mizo speaker here, so I'm not gonna do the Mizo ones. So one more time, like this time, hopefully it works.
Tongue,
Falling, low,
tongue,
rising, right? So a very interesting tone system actually, very distinct in that sense. Only thing that we have a little problem is with the Mizo low tone. Mizo low tone, which is a little bit falling, and it is often confused with the falling tone itself. So if you look into, so what we have done is that this is probably from about 50,000 tokens, 50,000 recordings of different mesotones, and from this we have got this. Wendy has done extremely interesting and hard-working work on this. If you look into this, what we have done is that we have collected all the Mizo samples, then we have normalized it. And some of you might already know what is normalization. As each of us have different vocal ranges, our fundamental frequencies are different, what we do is that we use mathematics to take out ourselves out from the data, so that only the tones remain, but we don't remain there. So what we do is that we basically subtract the average fundamental frequency of the person and divide it by the standard deviation of all the tone data standard deviation, and then we get certain values which are between a plus value and a minus value, as you can see. Now you can multiply this with any of the average. Can you multiply it? No.
You add and multiply. Yeah.
No, multiply and then this thing.
Yeah. First
You have to.
deviation and then, yeah.
You have to absolutize it, because like there is minus, otherwise minus.
Yeah, but you plus, you add.
That's why I have a mathematician in the room. Thanks. So now we have this plus 1 to minus 1 values here, as you can see, and this is the meso falling tone, nicely represented, rising, and this is like, you know, basically high tone, which goes a little bit high here, reaches some sort of high kind of target, and then goes down, and maybe the high tone, short high tone must have gone up till here, who knows, right? And then the low tone, as you can see, it goes a little bit like falling tone way here, right? So very interesting tones, because these tones we can now represent it into two ways. When a meso speaker probably hears these tones, he or she hears it in two different ways. One, what is the height of the tone? And second thing is that where is the tone going? Is it going up, going down, going low and high? How is it going? And based on that, the meso speaker makes a decision whether it's a high tone array or whether it's a famous to stay, greasy, or trap. Angami speakers are not that lucky. They have to listen to that whole, like, you know, like average fundamental frequency, because they are all level, and it's a really, really complicated task. Until and unless you have a little bit of more prosodic context, you are probably not going to get which tone it was produced. This is the case of ow. This is what one of our students, Moa, has worked on. In ow, we have three tones. This is high, low, and mid. I don't have to tell you which is high, low, and which is mid. So what happens is that these are all, again in ow also, these are all three level tones basically, and it has been shown in several literatures. Temsu's work is there, a kind of a masterpiece if you look into it, where he has talked about the tones and morphology in ow. However, what we have noticed is that there are three major ow dialects that we have looked into. One is Chungli, which is considered basically the standard. Then we have the Mungsen, and then Chanki. There are three varieties of ow, and we have collected for a long time. We have collected data on these ow tones, and then that resulted in Moa's dissertation, Automatic Dialect Identification in Ow, a Low Resource Language. Again, I encourage you to go and read that one too. So when we look into, like, you know, this ow realization of these three tones in ow, this is not a very pretty picture, so sorry about that. But the point is very clear here. Across all the speakers of the three dialects, you can see here, like, you know, the high tone is somewhat here between 0.5 and 1 for this is for chunky speakers. For Mungsen speakers, it goes much higher, and the difference between mid-tone and low tone is much more for Mungsen speakers, whereas in the other cases, like, you know, the differences, they are almost equidistant there, right? Now these are, like, you know, these are, like, if you ask any of these speakers, probably they would not consider these differences as very big differences to be, like, you know, cognitively very significant for them. They would not consider, like, you know, that it is a different category. However, we assume that in case of, like, you know, dialect identification, when the person's like, you know, which dialect he speaks or she speaks, that is determined, these information are useful, and these informations, these micro prosodic variations basically come into work unconsciously for the speakers. So what we do is that see, now there are two ways of dealing with it. I can go and make these kind of tones, and I can go to a bunch of our speakers and ask them whether you hear the dialect or not, if I make the difference this much. Another way is also just to give it to a machine that, okay, so these are these three dialects, right, and I'm giving you all these different tones. Can you predict correctly, or can you predict differently or not? So we did that actually at some point of time. Okay, so this is what the whole result of part of the result of Moa's dissertation is. If you look into it, I would not delve deep into it. If you look into that, these are MFCC features. This is I forgot even that SDC. It will come to my mind in a minute. Shifted delta Capstral coefficients, right? And then using these two features, you get this kind of accuracy. But I'm not concerned about this. I want you to look into this part. So when we are looking at only the F0, right, when we take the average F0 of the three dialects, right, we are getting actually an accuracy of about 43%. To take the F1 score or accuracy, 43%. So that is not a very high 90% case, but it is still better than the chance level. What do I mean by chance level? So what is the possibility that by random selection you will be able to get the correct dialect? That is because there are three dialects and there is one possibility, so 1 by 3, 33.33 is the possibility. If you cross that, that means your selection is not because it is random, because you are making a conscious decision, or the machine has learned and made a conscious decision. If it is below that, we know that the machine is just guessing, as many of us have done in our exams earlier. So here what we see is that is much higher than this 33.3. So it convinces us that the machine has learned something, at least from only the F0 information, and it is able to get the dialects correctly identified. Some dialects it does not, because we don't have the complete information here. Some dialects it cannot identify very well. Some dialects, for example, you saw the middle one there, right? The Mongsan it can do it very well, but Chanki and Chungli it finds it a bit difficult because they are almost the same values here. However, as I have again reiterated, these subtle tone differences are not probably phonological differences. You will not probably hear it as a completely different tonal category, or or will not confuse a mid-tone with a high tone, etc. Right? However, unconsciously, they are probably helping you to identify the speaker. I must also clarify at this point of time, this is not to assume that other things remaining the same, only the tones are changed in the three dialects, because there is a substantial lexical variation across the three dialects in Ao also. However, there are several overlapping vocabularies in the three dialects, which we used in determining the dialect identification in the Ao dialects. Okay. So as I said, these differences that you see, the acoustic differences that you see, they may not shift the perception of the tone category per se, but it is enough to get the personal information, person-specific information, which is about what dialect the person is speaking. So now I come to the other case where I discuss rhythm, and then rhythm is basically a temporal measurement in speech. So apart from, let's say, number of how many syllables that you speak in a second, how fast or how slow a dialect is, there can be more complex measurements of the temporal characteristics, or the time duration wise characteristics of speech. One of the clear things that has come into people's mind is this Morse code or machine gun type of rhythm. Some languages are supposed to be a Morse code kind of rhythm, like ta 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 ta, kind of rhythms when people speak. However, in many languages, specifically, let's say like when you listen to Chinese, you always hear ta 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 ta. There, all the each syllable seems to be of equal duration, right? So based on that, the world's languages are divided into two types. They are like figuratively talked about as Morse code type or machine gun type. I probably don't have to tell you what machine gun sounds like, but Morse code I probably have to. We are more used to machine guns than Morse code probably. So Morse code sounds like ta 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 that way, and machine gun you already know. So based on this, the machine gun type is basically like something called the syllable time languages, and the Morse code type is called the stress time languages. So when we are determining this, Pike was Pike again. Like if you remember Pike, he's also well known for his treatise on tones. Right, one of the first comprehensive writing on tones. Right. So Pike's 1945 work, it talks about that languages fall into two distinct rhythm classes, and so one is stress time, the other is the syllable time. And then isochrony, or having the same time duration, is actually one of the basis of these kind of differences. So in case of a syllable time language in case of a stress time language like English, each syllable may be very different from the other syllables different duration. However, in a syllable time language, why did I say syllable duration varies? But I don't know. But anyway, so in case of stress time syllables, each syllable may not be of equal duration. In case of syllable time languages, each syllable is usually of equal duration. So you can hear them as machine gun type versus the oft mentioned Morse code type languages. So there are many different ways of looking into it. Some of these differences also basically emerge from the fact that languages have different syllable structures, or languages tend to make syllables in different ways. So when I talked about the Chinese type of languages, you already know that Chinese has very limited type of syllable types actually, like Japanese or Chinese. They have very limited type of syllable types compared to, let's say, English type of languages, which might have very complex kind of syllables in their inventories. So then in later, people also talked about that there are different phonotactics that are associated with this rhythm values, etc. We will not go into that complexity now, but we will go straight into one work which was considered fundamental in the current works that are being done on rhythm variation in languages, which is the Ramos's work, where it was proposed that Ramos was the first one probably to propose these measures, where he talked about that there are some measures which can actually capture these rhythm variations like syllable times or stress time. For example, delta C, which is basically the standard deviation of all the consonant durations, and you take that look at the standard deviation of the consonant durations and you get delta C. I don't probably have to make you understand what standard deviation is. If you still have some confusion about standard deviation, please you can talk to Uri. Percentage V is very easy in total utterance. How much of the total utterance contains only vowel sounds? That is what you try to determine. So if you are if you have about 50% of it, you know that it is going towards more like syllable timed languages. Similarly, you might have delta V, which is standard deviation of the durations of the vocalic or the vowels. And also, apart from that, there are some other measures such as PVI, pairwise variability index, or NPVI, normalized pairwise variability index, where they look into the first vocalic or the first vowel versus the difference to the second vowel versus the difference to the third vowel and the fourth vowel, and on, and then they sum up the differences and then they get the NPVI or the PVI. Right? So all these measures are basically used to determine whether a language is a stress time language or a syllable time language. A higher delta C and lower percentage V are associated with stress timing. And if you think about it logically, then you will get the idea immediately, because you know that as I told you, the stress timed languages would have varying duration of each syllable, right? It will vary. One is short, long, short, long, short, short, long, something of that sort. On the other hand, syllable time languages will have the same duration, same duration will go on. So the delta C will be lower. There will be not too much variation there. So the standard deviation will be lower, right? So, and then percentage V also will be lower in case of the stress time languages, but not the syllable time languages. In one of the first representations, when they got this delta C and percentage V measurements, they basically represented the delta C and percentage V values in a plot like this. You can see that on y-axis you have delta C, on x-axis you have percentage V, and there are actually three classes that you can clearly see here. Here is the English, this is probably Dutch, and this is Polish. They fall, sorry? Portuguese probably, okay. So English, Dutch and Portuguese. Polish would be syllable time, yeah. So these fall into one group. These fall into Spanish and the French and the other languages, Italian, etc. They fall into this group. And then here is a lone group of Japanese here. So these are considered to be the stress time languages. These are supposed to be syllable time languages. And here Japanese falls into a very exclusive class, which we call the Mora-timed languages. Later, much later, I mean, several people, Japanese scholars have argued that there is nothing called a Mora-timed language, but that's a completely different sort of argument that you can look it up later. The reason why I'm telling you the exception is that don't take it for granted that everything said is actually is the current truth, because there is hundreds of papers and works published every day, and you will have exceptions and contradictions in every work. So my point is to encourage you to read more about what people are saying now. Takayuki Arai's work, for example, he actually he was not very happy with this Mora-timed label. Nevertheless, we now have the three categories as I have talked to you about. Here, each syllable has equal duration. Each syllable does not have equal duration. Here, Mora, each Mora has unique duration. But now, what is a Mora? So if you want to know what is a Mora, then you have to skip lunch and meet me after the lecture. Nevertheless, so our question was again something related to this. Now, when we talk about rhythm, do we have actually dialect specific or language variety specific rhythm that we can posit? So what we did is that in actually in Lina's work, we have tried to look into 5 Assamese dialects or 5 Assamese regions from Assam: Tinsukia, Jorhat, Nagaon, Borpeta and Nalbari. These are the main areas which we can distinguish as Eastern Assamese, Central Assamese and Western Assamese. Right. And then what we did is that in one of our works, we tried to give this rhythm values, get these rhythm values and see where they fall. Interestingly, what we see is that all these Nalbari, Tinsukia, Nagaon, Borpeta, Jorhat, they fall somewhere between the syllable time and stress time, somewhere aligning around Japanese for some reason. In fact, later when we looked into the Mizo data also, Mizo also fell somewhere in the same area. So what is happening? We are not very sure, and also we are not very sympathetic to this strict categorization of languages according to tight, watertight rhythm compartments. So we are not we are not taking that as an indication that it is a Mora-timed language. There may be 100 other reasons why they actually fall into that group. Nevertheless, my point here is to show you that these languages don't fall here, neither here but somewhere in between. Of late, last month, in fact, no, not last month, in November 2024, we have presented a paper where we have shown that these rhythm classes of Assamese speakers speaking English is actually very different from the same Assamese speaker speaking Assamese. So we have some databases of Assamese speakers speaking English and Assamese, and then we have extracted the rhythm measures. What we see is that Assamese speakers, when they speak English, and we looked into two medium of instruction, Assamese medium students and English medium students, they all are somehow around here, right? Not quite British English, but somewhere around here. But the same speakers, when they speak Assamese, they actually go up and meet our old contendants down here, right? So that also makes us think a little bit new, afresh about what is happening. Why are we so English, is it that foreign to us that we are actually implementing a completely different rhythm class, rhythm characteristics for while speaking English versus while we are speaking our mother tongues, right? But those were red samples. And as I told you in the first slide, that remember, register, the way you read it is actually very different, and that might result in very different outputs. So now our work is to see whether spontaneous speech also has the same characteristics or not. Spontaneous English and spontaneous Assamese, would it have the same characteristics as read Assamese and read English by Assamese speakers? If somebody else publishes a paper before I publish this, I'll get to know how they did it. So this is the the whole group that I'm talking about. So what we did is that after that we tried to put this data of the rhythm, right? This different rhythm measures that we have collected, such as as you can see, these are the different rhythm measures: percentage V, delta V, Varco V, delta C, Varco C, NPV, etc., etc. So we got all these different measures, and we gave it to the machine. We said that, see, these are 5 different languages, 5 different regions of Assamese, and I'm giving their values. Will you be able to predict the region correctly? So it told us that it can do it 42, almost 43% with 43% accuracy. Now, what is the chance level in this case? 5 regions, and you have to put it in one of the classes. So what is the accuracy now? What is the chance level now? 1 by 5, right? 1/0.2, right? So there is 0.2 or 20% is the, am I correct? Okay, 20% is the chance level, right? It's always good to confirm. So 0.2 is the chance level, and it is doing almost double the chance level. So we are quite comfortable saying that there is something about that regions or dialects that this rhythm measure basically captures. So the 3 dialectal areas, if we consider them not as region, 5 regions, but let's say 3 dialectal areas like Eastern Assam, Central Assam, and Western Assam, then I get a total accuracy of about 47.4. Don't look at it for the time being. You may like to read the paper, which is down here, if you are interested in that. We are not going to spend time explaining why it is here, but here the best result is here. Here, if we go by region to 5 regions, it's about 43%, 42.8%, right? So now, as far as rhythm is concerned, again, we don't clearly hear any rhythm differences. I mean, at least it is not as marked. There are lexical differences that are marked between these 5 regions of Assamese. There are pronunciation or phonetic differences that are marked between these 5 regions of Assamese. But it never occurred to us that there would be, or it was not apparent to us that there is any rhythm difference that is there among these 5 regions of Assamese. But somehow the machine is able to capture these prosodic rhythmic variations of these 5 areas and tell us that these are actually different areas. And given a dialect, I'll be able to, there is 42% chance that I'll be able to tell you which town this person is from. right? So what is the point here? So various phonetic features, as we have seen, like throughout, like we have seen the consonantal features, we have seen the vowel features, we have seen the different prosodic features. All these features are able to actually capture the variations in languages. These prosodic features such as F0 in the tone languages and then the rhythm features that we have talked about, they also are able to capture the dialectal nuances in these languages. However, there are some other features also. For example, intonation, which is a much more bigger domain. And as I was telling you, I like working on only 100 milliseconds, 200 milliseconds. But if you go to intonation, it's a pretty long, it's a pretty big business altogether, right? So what happens when we go on to this intonation level or the sentence level? So this is something that you are probably going to try and do over the next few days in this course, where when you are recording these sentences. Probably one of the things we might try to do is to see whether we can get the data extracted in terms of intensity, loudness, and in terms of F0 characteristics from the whole sentence itself, and see if we can model these dialectal differences or these linguistic variations that we have in this classroom, if that can be captured through those. Again, the question remains that are there holistic ways to capture them rather than going through this cherry picking vowels, cherry picking tones, cherry picking rhythm. Is there any one way that we can get all these features captured? And the answer is yes, because the methods that that Uri is going to probably discuss later, where you get certain values extracted or certain features extracted from the raw speech file, that includes hundreds of columns of features or hundreds of features. About, let's say, minimum 500 features probably is usually extracted. And then in those features, the problem now is that you have a lot of these micro variations that will be captured, but at the same time there will be a problem also. We will not know, like F1 and F2, we immediately know we are capturing the height and the backness of the vowels, right? Rhythm, we already know that we are getting the isochrony of the sentences, but when these 500 features come in, these 500 features are not easy to explain what causes their existence or their differences. However, we will be able to do better classification as the features increase, and that is what Uri is going to talk about. So I'll stop here. If you have a question, I'll take it.
Yeah. So Japanese language is considered, it has accent tone. So
pitch accent, right?
Yeah, pitch accent. Yeah. So how is it different from lexical tone? Can you explain?
Yeah, it is not a very easy question to answer, but nevertheless, let's say in the lexical tone languages, at least one easy way to see it, in a lexical tone language, there you will have only, even in a single syllable, you will be able to have two kinds of or three kinds of or more than that tones, right? In pitch accent languages, it is usually contrastive. So if it is the tone is on the one of the marked high tone is on the first syllable or the second syllable, based on that the meanings change. For example, in Japanese, can I have this? In Japanese, for example, you might have a difference between a word like ame versus ame, right? Where you do the H high, which is one of the marked accents in Japanese, would, depending on whether it is on the first syllable or the second syllable, the meaning basically changes. That usually is not possible to be done in only single syllable in Japanese, right? And also another thing is that these accents, they have their own patterns. For example, Japanese only allows certain types of, for example, high, low, low, high, low, high. I cannot recall it very well at this point of time, but the number of such combinations are what is allowed in the accent system are very limited. But again, if you are interested, then Moira Yip's book.
We asked you all, people here and people online all over the place. We asked you to record some North Vietnamese in English and in your language. We will slowly start collecting those recordings. Tomorrow we hopefully start building a database together. That's the plan tomorrow afternoon. The one thing which will be kind of required for this and for the other things is for you to have a Google account. I guess most of you would have a Google account by now, Gmail or Google account. If you don't, can you please sort of make one? We will use a Jupyter notebooks and things like that, which are the easiest sort of implemented through Google, and we will sort of collect all the data through the Google account. This is not an easy thing to say. I don't want to sort of force you into this sort of kind of corporate greedy type of the world, but this is the easiest thing for us. So if you have some objections to having a Google account, let us know and we will sort of somehow sort it around. You might sort of participate in somebody else's work, but that would be the easiest. So let's start with that, and we will start maybe sending your way some documents to fill and instructions where to upload things and all that. Thanks.
So I can see a couple of questions in the chat. One was at 11:15 actually, which is by Avantik. How do you not let areal similarities between languages confuse you from establishing genetic links? So that is what one of the points that was considered to be exceptions to that comparing these kind of data, that first you have to make sure that it is not the case that it is a simple borrowing from the other languages. And are tonal languages also, second question is, which is very interesting question, are tonal languages also syllable timed? I would not think so. I would not think so. They would probably, I think because of Chinese, one may be tempted to think like that, but in case of Mizo, at least we saw that it is not a syllable time language. It falls somewhere between stressed and syllable. And somebody said, who was the researcher who was not happy with the Mora timed analysis? So that was the researcher who was not happy with calling Japanese a Mora timed language. Was now I don't remember. Takayuki Arai. Arai has a paper, but I can see a lot of the researches that I'm talking about. Actually, I'm also preparing a bibliography, so I'll share with you, as maybe next year. But I'll hopefully do it soon. I already have it written down there.